Hello, we're continuing the PRMS training video series. I'm talking about the solar radiation distribution process and the modules that you can use. Basically, there are three. You can see them down there: DD SolRad, CC SolRad, Climate HRU, and basically you can specify which one of these three you want to use in the control file. The job of these modules, or what needs to be done by this process, is we need solar radiation at all the HRUs, and we've either got it at a point or we have the tables, the solar tables that came from the solar table process, and we need to come up with the daily solar radiation on the HRUs, and that's what this is about. So in the case of the DD SolRad, or degree day module, basically you can see the equation down here. This variable here, SWRAD, that's the solar radiation on the HRU, on any HRU on any given day. And you can see these two graphs here. Basically what you do is you enter this left-hand graph with the daily temperature on the HRU, maximum temperature. You come up and you see these two parameters, D-day slope and D-day intercept. They define this line, so where that temperature comes up and intersects the line, you come across to this this curve over here on the right-hand part of the graph, and then you intersect that, and then you come down. And then what that does is it gives you this value of, in the code it's called SOLF, and basically what it is, the ratio of actual to potential solar radiation. And then that value is used in this equation. So here you've got the SolTab pot SW, that's the value that comes from the solar table. And you've got this parameter here, HRU slope. So you've got all the values you need, and then you compute the daily shortwave radiation on the HRU. And then we can look at the other module, the CC SolRad, or cloud cover solar radiation estimation. You can see the equations here. Basically, Tmax and Tmin, those are computed for each HRU. You've got these two parameters. Cloud cover plugs into this equation. CRAD, COF, that's another parameter. So from those equations you're able to compute the SOLF value, and then it's the same equation again. SWRAD is equal to the same equations. It's different ways of computing this ratio of potential to actual solar radiation. One thing we do, and I included this, is we get these maps of solar radiation. These are expected actual solar radiation from from NREL, the National Renewable Energy Laboratory. So if you're putting solar panels on your house or something, this would be the information that they provide to you, but we use it to calibrate our model. And in this case, you can see how solar radiation is varying spatially and by month, and these are good calibration data sets. One final thing on this solar radiation distribution process, there's always a question about units. And so our modules are outputting solar radiation in Langleys, which is 1 calorie per centimeter squared. And for those of you who forgot your high school chemistry, a calorie, the definition of a calorie that we're going to use here is raises 1 cubic centimeter or gram of water 1 degree C, right? So very convenient units to go from energy directly to temperature. Then if you're thinking about a more modern or common set of units, is watts per meter squared. You can see the conversion factor between 1 Langley per day to watts per meter squared. So That concludes the solar radiation distribution modules.